All right, we're going to take up a test here. I want to just go through these questions here. So this is a factoring test on quadratics. Looking at factoring quadratics, there's some expanded and simplifying terms as well. So let's go ahead and take a look here. So the first part of this assessment was fully factor following expressions. So we start off with a simple trinomial here. Again, I know that's a simple trinomial as the leading coefficient is 1. So I need to think of two numbers that multiply to be 30 and add to be 11 in this case. And if you go through that, you're going to find those numbers are 6 and 5. So this first question will factor into k plus 6 times k plus 5. Or again, vice versa, you could have k plus 5 times k plus 6. Moving along here, now we've got another expression here. So whenever you're looking to factor something, the first thing you want to look for is a GCF. I'll notice that this has a GCF of 4, leaving me with a squared plus a minus 6. And then inside the brackets here, I now once again have a simple trinomial. With a simple trinomial, I need to think of two numbers that multiply to be negative 6 in this case and add to be 1. Going through those two numbers, you're going to find them to be 3 and negative 2. So don't forget to write this 4 back down. A lot of times students will forget. So this will be 4, and this should factor into a plus 3 times a minus 2. All right, let's take a look at the next one here. So in this question here, this looks a lot like a quadratic. It resembles the quadratic r squared minus 10r plus 9. So we're going to go ahead and factor this as a simple trinomial. You'd end up getting r minus 9 times r minus 1. But again, it's ending in an s squared. So to get your factored expression here, this will be r minus 9s times r minus s. And this would be the answer for this one here. So by tacking the s's on in the back here and expanding that out, you'll get your 9s squared that you want. And also taking r times s and negative 9s times r, collecting those together, you get your negative 10rs. All right, taking a look at the next question here, we've got ourselves a complex trinomial this time. I know this is a complex trinomial because that leading coefficient is not a 1, and unlike the previous examples, I cannot factor that out. So we have to go ahead and do our charting here. So all the factors of 2 and the flips, and I'll go ahead and do all the factors of negative 21. And I want this combination to be such that I end up getting a negative 1 out of this. And as you go through these combinations here, you'll find that if I take this column and this column together, you'll take these two together, that'll give you a negative 7 when you multiply. Taking these two together, that'll give you a 6. Adding those together, you get that negative 1 that you want. So this will factor into, reading this from left to right, we get 2m minus 7 times m plus 3. And that one is factored. Let's take a look at another. So for this problem here, same idea. We want to go to charting. So this is 10 and 1, 1 and 10, 5 and 2, and 2 and 5. And then the factors of minus 3 are going to be negative 3 and 1 and negative 1 and 3. So again, I'm trying to find columns that give us a 13 when we do our math on this. And quickly you'll find these two are the ones that work because 5 times 3 is 15 and 2 times negative 1 is negative 2. Add these together, you do in fact get your 13. So this will factor into 5x minus 1 times 2x plus 3. And that one is done. Let's take a look at the next one here. So for this one here, again, always look for a GCF on this. I have a GCF here of mn. So factoring out the mn, you're left with 2m squared minus m minus 21. And you'll see here that this expression is exactly like the one we had done previously. If you go up top here, we had just factored this, and it factored into the following expression here. So we can just go ahead and substitute that in right here, and this ends up being mn times, don't forget that mn from before, as there was a GCF on this one, unlike the example above. But this will be our final answer. So again, normally if you didn't see the question before, you'd have to go through your charting on this, left with a complex trinomial like we've been doing, but that is not the case. So for the next one here, you're given looking like a difference of squares, but you always want to look for a GCF, and I can see I can factor a 2 out of here, leaving me with 1 minus 100 y squared. And then I can go ahead and express this as powers of 2, difference of powers of 2. And then our difference of squares formula kicks in, give me 1 minus 10y and 1 plus 10y. And that is our answer for the next one. Continuing on here, again, difference of squares. As long as I can write these as power of 2, which I can rewrite the 81f squared as 9f quantity squared. And likewise, I can write that as 16 as 4 squared. This will factor into 9f minus 4 times 9f plus 4. All right, continuing on here, I see a GCF on this. GCF is a 7b, leaving me with 9a squared minus, in this case, a 4. And we had just factored this above. This will factor into 3a minus 2, 3a plus 2. And again, how I got that is you can write this expression as 3a quantity squared minus 2 squared, and then your difference of squares formula kicks in, and you've got your final answer. Continuing on here, again, another difference of squares question. We got 2x minus 1 squared minus 7x plus 4 squared. So using our difference of squares, this is the place of x, this is the place of y, so it's going to be my first expression minus my second expression times my first expression plus my second expression. Going ahead and distributing that minus sign here, we get negative 7x minus 4. And we can leave this one as is. Collecting like terms here, I get negative 5x minus 5. And this becomes 9x plus 3. You'll notice I can factor minus 5 out of the first one, leaving me with x plus 1. And the second term here, I can factor a 3 out of this one, leaving me with 3x plus 1. Collecting this all together, we get negative 15 times x plus 1 times 3x plus 1. And we are done. Moving on, here are two different types of problems here. They want us to take a look at expanding and simplifying the following expressions. So with this one here, you're going to go ahead and square the first term, giving you 4x squared. First times second times 2 is minus 16x. And lastly, you get 16 when you square the last term. Distributing, so doubling all these numbers, we have our expanded and simplified expression. All right, final question here. We want to go ahead and evaluate this expression. So before you distribute that minus 3, you're going to want to take care of this. So I'm going to go ahead and write that minus 3 down. This is going to end up being 5x plus 5 minus 2x squared minus 2. And then we're going to go ahead and take care of this as well. Don't forget to put brackets around this whole thing. So square the first, you get x squared. First times second times 2, and square the last. I'm going to go ahead and distribute this minus 3. Actually, before you distribute the minus 3, you should always simplify. And you can see here I can collect up like terms. The x and x squared do not have like terms, but the constant terms do. So I can simplify this to become minus 2x squared plus 5x plus 3. I can distribute the minus sign here into the trinomial. And expanding this out here, I get 6x squared minus 15x minus 9 minus x squared minus 2x minus 1. So then you can go ahead and collect like terms this time, and you'll see here I've got a 6x squared. I can connect up with my minus x squared. The minus 15x I can collect up with a minus 2x. And lastly, the minus 9 with the minus 1. So we end up getting here 5x squared minus 17x minus 10. And that ends up being our simplified expression. All right, that concludes this quick run-through of some quiz solutions that we had here. Thank you.